Okay, so today we're going to take a break from all of the angles and the new words and all of the new things that you've never seen before, and we're going to go back and do some things that you definitely have seen before. We're going to talk about area and perimeter. In geometry, we're going to work with lots of shapes. We're going to work with lots of triangles, squares, rectangles, circles, and we're going to do some more shapes that we're not going to talk about today. But one of the things that you're going to have to be able to do just almost on command is find the perimeter and the area of these shapes. And it's what makes it great is there's formulas for it. So you don't have to think about what do I do to find the perimeter of a triangle? Or what do I do to find the perimeter of a rectangle? How do I find the area of a circle? There's a formula, and you have access to these formulas. You can look them up anytime you want. Even if you're out somewhere and you need to know the formula for the area of a circle, you can Google it and it'll come right up on your phone. So we're not going to spend too much time talking about these formulas. You've been exposed to these before. If you have any questions, be sure to ask. The one thing that I do want you to remember when you're talking about formulas, all of these formulas talk about base and height. Now they might say side or length and width, but it's also base and height. And the key is that the base and the height must be perpendicular to each other. So as long as you don't get confused about that, you're going to be fine. Where you're going to have problems is if you start to think that this is the base and this is the height. And you're going to get tripped up on a lot of these problems. So as long as you can keep that straight, you're usually pretty safe. So let's start with example 1 and problem A. We got a rectangle. I'm going to go ahead, I'm going to divide this up into little sections. So let's do the rectangle, and we're going to find the perimeter, and we can look up and see that the formula says that the perimeter is 2L plus 2W. Well, that's 2 times 6 plus 2 times 4, so 12 plus 8. So our perimeter is 20 inches. Not bad. Then we're going to go for the area. Look up at the top, and our area formula is length times width, which is 6 times 4. So the area of this rectangle is 24 inches squared. And the way we say this is 24 square inches, but the reason that it's squared is because we did 6 times 4 to get 24, and we did inches times inches, so we basically did inches times inches, and that would make inches squared. So don't overthink it too much. Just remember, if you're doing perimeter, it's inches. If you're doing area, it's inches squared. So let's do the perimeter of this triangle. Now the formula for the perimeter of the triangle says P equals B plus C plus D. I wouldn't worry too much about remembering that formula. I would just remember that you're just going to add up all three sides. And that's how you find the perimeter of any triangle. So the perimeter here is 29.2 inches. Now the area of a triangle is a little bit trickier. You see the formula says area equals 1/2 base times height. Well, that's 1/2. Now the base of the triangle is the entire bottom. It's whatever it's sitting on. It's 10.2. The height of the triangle is always perpendicular to the base. So the height is 8. So 1/2, you can use the calculator for this, right? So 1/2 times 10.2 times 8 is 40.8 inches squared. That's the area of that triangle. And now let's do the circle. Circles are a little different in that circles don't have a perimeter. Circles have circumference. So you know with a circle, the circumference is the distance all the way around. So we look up at the top, and our formula says circumference equals 2 pi r, or circumference equals pi d. Well, a little reminder, R stands for radius, D stands for diameter, right? The diameter is the distance all the way across a circle, which is what we see here. The radius is half of that distance, which is just here. So that's the radius. So let's do it both ways. The circumference equals 2 pi times half of that is 3.1. Or the circumference equals pi times 6.2. Hopefully you know with multiplication it doesn't matter what order things are in. So this could just as easily be 2 times 3.1 times pi. The order doesn't really matter. So 2 times 3.1 is also 6.2. So either way, we have the same answer. And for now, let's just leave it like that, because we want to get used to leaving the pi symbol in our answers. Because I'm not trying to paint this circle, I'm not trying to lay tile on it or build a deck on it, so I don't really care how long it is rounded to the nearest tenth or anything like that. I'm just going to know that it's 6.2 pi. Now let's do the area real quick. Area formula up at the top says pi r squared. R is the radius, right, that we already found out. This radius is 3.1. So we're going to do pi times 3.1 squared. Now, the order of operations, we do the 3.1 squared before we multiply by the pi. So 3.1 squared is 9.61. And again, we just leave the pi alone. There's no need to move it around or multiply it in here. So we're not going to gain anything by doing that. So just leave it there. And that is centimeters squared. So there we go. Hopefully you remember perimeter, area, circumference. So last page, last example, last set of notes for this first unit. We're going to find the perimeter and the area of triangle ABC with vertices A, B, and C. What that means is find the perimeter and the area of this triangle, but to do it, you're going to have to graph the triangle. So let's start with a graphing. Hopefully we remember how to graph from algebra. Point A is -1, 1, 2, 3, 4. So that's point A. Point B is -1, -1. Point B. And point C is 1, 2, 3, 4, 5, 6, -1. So that's point C. And now we're going to connect those dots and we're going to make a triangle. Now how would we figure out how long the sides of that triangle is? Lots of things we could do. We could do the distance formula that we learned a long time ago, right? We could do the x1 and y1, x2 and y2, and then we got an x3 and a y3. Ugh. That doesn't sound like fun, right? Why don't we just count the squares? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And we have a problem here, right? Can't exactly count those squares. But what we can do is the distance formula just for this side. So we're going to go from A to C. So A will have x1, y1. We don't care about B because we don't need to, we know all the distances for B. And C can be x2 and y2. So to find out the distance from A to C, we'll do the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared square root of x2, which is 6, minus x1, which is -1 squared, plus y2, which is -1, minus y1, which is 4. So we just keep on going with this, and 6 minus -1 is 6 plus 1, so that's 7 squared, plus -1 minus 4 is -5 squared, so that's the square root of 49 plus 25, which is the square root of 74. So that's what our distance equaled. So we're going to go ahead and put that up here, that this is the square root of 74. Now, to find our perimeter, we just need to add up the 3 sides, right? So we'll do 5 plus 8 plus the square root of 74. So again, don't get caught up in trying to make it complicated. Just write down what it says from the pictures. If you have a 5 here, you have an 8 here, and you have a square root of 74 here, then that's what you write. Combine things that you can combine. 5 plus 8 is 13, plus the square root of 74. There's nothing further you can do with this. So this is the answer. What we're going to have to work on is getting comfortable leaving these square roots or these radicals in our problems. Two of the most difficult things for you guys to leave in your problems are going to be the radicals and the pies. You just have to leave them alone and move them around. Let's do the area now and we will be done. So 1/2 base times height. It's 1/2. Remember the base is right here, 8. The height is 5. So it's 1/2 times 40. Well, 1/2 of 40 is 20. So the area equals 20. Now, you might say, well, area was supposed to be squared, right? So there's no inches or anything like that. So what we're going to do on both of these is we're going to add on the units. But we don't have any units, so we're just going to call them units. So anytime you don't know the unit of measurement, it's just units, and area will be units squared. And that's it.